This is the fourth in a recent series of meetings on the Bird Machine site to present, kind of where we are with the cleanup process out there. I'm Chris Clodfelter with Baker Hughes, the manager of the project, the director of environmental affairs. Our consultant is AMAC. There's Kim Henry, the licensed site professional, and then Mark Grant, the project manager. And so what we're here to do tonight is provide a kind of a picture of where we are, the environmental status of the property, listen to community concerns and questions, and tell you about our plans for future site use. We've done a lot of voluntary remediation at the site to date. We think it demonstrates our commitment to protect the community, the environment, and health and safety. And as I mentioned in previous meetings, we've spent, now we're over $9 million we've spent on this project. And Dina, I don't know if you had any words or not.
I think you summed it up. I'm just happy to participate and provide any information that might be needed and support the effort.
Okay, great. And so kind of the agenda for tonight's meeting, we're going to talk about our recent activities. We're going to summarize a recent draft document that we submitted and from which we're soliciting public comments on. And that document is our Phase 4 Remedy Implementation Plan. We're also going to talk about our future activities and also the future opportunities for the public to get involved with commenting or sharing information on the project. So with that, I'm going to turn it over to Kim, and she's going to go into the details.
If you come to our public meetings before, you've seen this slide. This summarizes the phased process under the state regulations that are known as the Massachusetts Contingency Plan. And it's a body of regulations for investigating and cleaning up hazardous waste sites. So this flow diagram shows the overall process under the Massachusetts Contingency Plan. It begins with investigations at Phase 1. There are more detailed investigations at Phase 2 for delineating contamination and assessing risks. And if you came to our previous site meetings, we presented the Phase 2 comprehensive site assessment for 3 areas on the Bird Machine property back in August. Those were the manufacturing building area, the lead release area 3, and the South Rail Spur area. We proceeded to Phase 3 with a public meeting in October, and then back in December we wrapped up the Phase 2 investigation for the last area of the site, the demolition debris area, and also presented the response action outcome statement for a temporary solution at the site. So where we are now is shown in yellow. We're at the Phase 4 Remedy Implementation Plan stage. Next slide, please. Let's see. So, as I mentioned before, we've completed Phase 2. As a result of the Phase 2 comprehensive site assessment for the 4 areas that I mentioned, for the demolition debris area, manufacturing building area, the lead release area 3, and the South Rail Spur area, we reached a conclusion that all the source remediation that Baker Hughes had done to date achieved a condition of no significant risk for soil, sediment, and surface water in those 4 areas. And what that means under the Massachusetts Contingency Plan is if you have a finding of no significant risk, you do not need to do any remediation. So basically what that told us is that the extensive work that had been done to date, that $9 million worth of work that Chris mentioned earlier, had been successful in addressing the issues in the soil. However, there's one remaining area of the site that does still need to be addressed, and that's the groundwater in the manufacturing building area. As this slide shows, there are several areas within the manufacturing building area where there are compounds present in groundwater above drinking water standards. So they do in particular, there is, as shown in yellow, there's a plume where arsenic does not meet drinking water standards. The orange area shows where chlorinated volatile organic compounds do not meet drinking water standards. And then finally, the green area is where another compound known as 1,4-dichlorobenzene does not meet drinking water standards. And I should also point out on this particular slide that this is really our worst case estimate of the particular areas of the site where we believe that the compounds are present above drinking water standards. But we do need to do some more investigation to refine the boundaries and get a more detailed understanding of where the compounds are present in groundwater. The other thing to note on this slide is that groundwater is moving to the northeast generally and discharging to the Neponset River that you can see runs along this boundary of the site. Next slide, please. So as a result of our phase 2 investigations, we developed a conceptual site model of how the compounds are moving in groundwater. As I said, our understanding is that the compounds are migrating toward the Neponset River, discharging to the river in groundwater, and then they're being substantially diluted in the river because of the volume of flow in the river. The diagram on this slide shows our understanding of what's happening in sort of a vertical slice through the subsurface. What we're looking at here, shown in orange, is our estimate of where present in the subsurface. We still have some questions about all the boundaries of this plume, but basically our understanding is that the ground, the groundwater, the compounds in groundwater are moving downward and then upward and discharging into the Neponset River. So this kind of gives you a three-dimensional picture of what. And to answer some of the questions that we have about delineation, our remedy implementation plan that I'm going to be describing in more detail addresses areas where we need more information about the concentrations and presence of the compounds. Next slide, please. So in December 2011, we had a public meeting where we presented the Phase 3 remedial action plan for the site. That's a document in which we evaluate the various cleanup options for groundwater. And as a result of this document, we concluded that monitored natural attenuation is the selected remedy for achieving a permanent solution for the groundwater at the site. Monitored natural attenuation is a process in which compounds that are present in the groundwater break down through physical, chemical, and biological processes that are occurring naturally in the subsurface. There are a variety of processes that occur. The primary natural attenuation processes that we think are occurring at the site are dilution, for example, in the case of arsenic, and then biological breakdown of chlorinated compounds. This diagram on the right shows a typical breakdown process through biological processes for a chlorinated compound called perchloroethylene, or PCE. So the diagram shows that the compound breaks down progressively into simpler compounds and ultimately to ethene and ethane. Next slide, please. So, as we've done with all of our documents to date, there has been a public comment period, and as part of the public comment period for the remedial action plan that we presented in the December, in the October 2011 meeting, and then we finalized that document in December 2011. As part of the public involvement process there, we did receive some comments from the town of Walpole regarding protection of water supply wells that are in the vicinity of the site. And the diagram gives you an idea of the relationship of the site to the town water supply wells. This is the site here, particularly the portion of the site where groundwater contamination is present, and then the town water supply wells are shown in the red dots, and those are more than 1.2 miles from the site. So we have delineated the groundwater in fairly good detail. We have no reason to believe that it has, made it the 1.2 miles to the water supply wells. In fact, as I said before, we believe that the affected groundwater is discharging to the Neponset River. We have a couple of clean wells on the opposite side of the Neponset River. However, we do need to do a little bit more monitoring to basically confirm our model and make sure that we understand where all the compounds are present. So to address the town of Walpole concerns, we're going to be adding additional monitoring wells to help in designing our monitoring network, and then selected wells will be incorporated into the monitoring network. Next slide, please. In December 2011, as I mentioned before, we did present a response action outcome for the last remaining release tracking number that's open at the site. The state of Massachusetts assigns release tracking numbers to the various releases at a given site, and we have succeeded in between 1992 and 2005 in closing out 5 other release tracking numbers that were assigned to the property. The last one, RTN 4-3024222, is the last remaining RTN that needs to be closed. So in selecting monitored natural attenuation as a groundwater remedy for the site, our intention is to advance the site from a temporary solution to a permanent solution. So we were able to say that we had reached a temporary solution in December 2011, and now our future work is going to be addressing advancing the site from the temporary solution to a permanent solution. We are currently at a temporary solution because site groundwater is not being used for drinking water, and because, as I mentioned before, soil sediment and surface water pose no significant risk. So we have met the requirements for a temporary solution, and in order to achieve a permanent solution, we need to achieve drinking water standards for the compounds that were present in the plumes that I described earlier. Also want to mention that in addition to all this work that's being done under the Massachusetts Contingency Plan, and in addition to trying to get to a permanent solution under the MCP, Baker Hughes is also evaluating opportunities for enhancing ecological services at the site, and that would be in areas such as land protection, creating and restoring wetlands and river habitats, and reforestation. So that's a summary of sort of what we've done to date. Any questions? Okay. All right. So for the next portion of this presentation, I want to walk through the contents of the draft remedy implementation plan. Just as a reminder, this plan was provided to the public for public comment at the end of February. And so we want to present the document here and continue to take any comments so that we can respond to those in finalizing our document. So this slide summarizes the objectives for Phase 4 under the Massachusetts Contingency Plan. Phase 4 is a three-step process for designing, building, and starting up the selected remedy. Where we are now is we're in the process of designing the remedy, and that is presented in the draft remedy implementation plan. Next slide, please. So our remedy implementation plan describes 2 field mobilizations that will lead to the construction of a monitoring well network for monitored natural attenuation. Each of these field mobilizations will require less than a month, and then we're also building in a data evaluation period between the 2 field mobilizations so that we can evaluate the data, and so that will bring the total construction duration to approximately 3 months. In the first field mobilization, our plan is to collect data to refine the positions for our permanent monitoring wells. So we're going to be using what is known as a geoprobe rig. It's a small mobile rig that allows us to install temporary monitoring points very rapidly. We combine that with a mobile laboratory so that we can generate real-time data to understand where the plume is, where the actual boundaries are, both horizontally and vertically. We will then evaluate the data that's generated from the first mobilization and use those data to select the placement of permanent, shallow, deep, and bedrock monitoring wells. And our goal there is to place the permanent wells primarily along the plume center lines, and which is where we would expect the highest concentrations to be in potential discharge areas. And then, in addition, a smaller subset of wells will be placed along the plume perimeter. So again, trying to understand better, both horizontally and vertically, the extent of the plumes.